Okay, finite math students. I don't want this video to get too long, so let's just focus on two problems, okay? Two problems in your finance homework. We're going to work on problems 60 and 82. Okay, so we're going to work on problems. Let me see if I can write this down. Problems 60 and 82 in your finance homework, okay? Okay, so let's take a look at problem number 60 first. And these are both compound interest problems. They are both compound interest problems. If $800 is invested in an account that earns 9.55% compounded annually for 6 years, find the interest earned during each year and the amount in the account at the end of each year. Organize your results in a table. Okay. So let's see. Let's define our function. What should I call it? F of year. Okay. Right, better than F. Let's call it amount at year. Okay. And that's going to be let's see, $800 times, or instead of times I could just write a space, same thing, 1 plus 9.55 divided by 100. Why is it 9.55 divided by 100? Because that's how you change a percentage into a decimal, okay? And then to the power of year. Okay, and that's your compound interest formula. It's very simple. Shift Enter. Okay. So we can fill out these amounts very easily. Table, amount year. Year goes from 0 to 6. And these are the amounts, although we really would like them rounded to 2 decimal places, right? It says here, do not round until the final answer, then round to the nearest cent is needed. So the way to do that in Mathematica is very easy. Number form and infinity, that means give me all the decimals, as many as there are, and give me 2 digits after the decimal point. And let's make it a table. Okay. So that's going to be, let's see, $876.40, $960.10, $1,051.79, $11,152.23, $1,262.27, $1,382.82. Okay. So far that looks good, but what about the interest? So to find the interest, we would need to subtract these amounts. We would need to subtract these amounts, okay? So $876.40 minus that. $800, right? And then $960.10 minus that, et cetera, et cetera. So you're going to take each subsequent value and subtract the value before. Okay, it's really that simple. Okay. Oh, excuse me. So table, number form, amount, let's see, amount year minus amount year minus 1, infinity 2, close the number form command. Year goes from 1 to 6. Not 0 to 6 this time, but 1 to 6. Okay, so there's no interest during period 0. And here we have $76.40, $83.70, $91.69, $100.45, $110.04, $120.55 Okay. So here you can see the difference between simple interest and compound interest, right? With compound interest, the amount of interest per period, it keeps getting, bigger and bigger, right? It keeps increasing. It's a little hard to write with this tool. It keeps increasing, right? Okay, so the amount of interest keeps increasing. So we start with $76.40, and then, it just keeps getting bigger, 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 until finally we reach $120.55. Okay, so that's the difference between simple interest and compound interest. With simple interest, these amounts would all be the same. With compound interest, the amounts keep getting bigger and bigger and bigger, right? So let's see what Pearson has to say. Okay, so that looks good. Okay. So for some of these problems, you're going to be creating a lot of tables, and Mathematica is very good at that. Let's look at problem number 82. Okay, this problem's a little weird, but that's okay. It's not that weird. I mean, it's basically just a regular compound interest problem, but there's a little bit of a catch here because of the commission rate, but that's not a big deal. Okay, so the buying and selling commission schedule shown in the table is from an online discount brokerage firm. Taking into consideration the buying and selling commissions in this schedule, find the annual compound rate of interest earned on the investment. Okay, there's my doggy, Chachki. Okay, so here's the statement of the problem. You can jump up, it's okay. I'm talking to my dog, guys. Okay, so the problem specifically says an investor purchases 85 shares of stock at $50 per share, holds the stock for 5 years, and then sells the stock for $110 a share. Okay, and I'm assuming that the rate of interest, that the rate of compound interest is annual, once a year. Okay. Identify the formula required to solve this problem. So this is your traditional compound interest problem, so it should be option B. So C is wrong. C is for simple interest. We're interested in B. Okay, that's correct. And now it says the annual rate of interest is. So, okay, so we have to figure out the answer, and this is going to be a little tricky. So let's see, 80, here, let me move this window over. 85 shares of stock, $50 a stock. That's $4,250. Let's see. So $4,250. That's going to be right over here in this category, right? $4,250. So that means $57 plus 0.6% of the principal. That's the commission rate. All right, that's the commission rate. So it's going to be, hold on one second, $4,250 plus plus $57 times 0.0006 times 4,250. And that's going to be $4,395.35. Now, by the way, when I type that number into Mathematica, well, if I type a large number into Mathematica, look at the commas. I'm not typing those commas. Mathematica is automatically inserting commas for me because that is how I set up my copy of the software. So let me say this again to avoid confusion, because some people are going to be confused about this. If I type a large number into Mathematica, you're going to see a bunch of commas. I am not hitting the comma key. Let me say this one more time for people who are confused. I'm not hitting the comma key. Mathematica is automatically inserting those commas for me, and that's because of how I set up the software after I installed the software on my computer. If you don't want to see all of those commas, don't worry about it. You don't have to see them. I happen to like them. Okay? If you don't like them, that's your business. Okay? But the point that I'm trying to make is that you can customize the software, and when you're typing really big numbers, please do not enter commas. Do not manually enter commas, okay? That is not going to work. Okay. So then, okay, so I should store this in a variable. I should be like, let's see, how about initial amount is equal to, and I'm going to use the percent symbol, which means the last answer or the last result. Okay. Let's see. So then it says here, I'm able to sell the stock for $110 a share, right? So I have 85 shares of stock, and I'm able to sell each share for $110. That's $9,350. So $9,350 is in this category, right? So now this gets to be the tricky part, okay? Oops. So the commission rate basically means that the brokerage firm gets a little bit of your money. It gets a little bit of your money. So that's going to be $93.50. Oops, sorry about that. $93.50 minus $75 plus 0.30% times 93.50. Okay, so that's going to be $9,246.95. Okay. Oh, you know what? This is, I may have made a mistake right over here. This is 0.6%. You know what? It's, wait a minute. That's 0.6%. Sorry about that. That's 0.6. So yeah, I think I made a mistake there. So that should actually be, okay, I think that should be $5,703.50 because this is 0.6%. So 0.6% is the same thing as 0.006, right? And then here, this is $75 plus 0.30%, and 0.30 would be the same thing, yeah, percent. This is a percent. That would be the same thing as 0.003, and if you want to, you can add that extra zero, but you really don't have to. Okay. Yeah, so let me make sure this is okay. 0.006. Initial amounts. Yeah, we're okay. That looks good. And then 93.50 minus, let's see, $75 plus 0.0030. We really don't need to use that other zero, that extra zero, but you can if you want to. Times the principal. Okay, and so the final amount is going to be that. Okay. So then I'm going to use my formula. Final amount is equal to initial amount, okay, times 1 plus r. You know what? I did use r previously in a problem. Oh, there we go. It's fine. It's a symbol. 1 plus r to the power of 5. Whoop, to the power of 5. And let's see, solve. What is r? Now remember, this is a double equal sign. Shift, enter. So we're getting a lot of answers, but I only want the answer that's real. I don't want the answers that include imaginary numbers. I want the answer that's real. Oh, and let's flatten that. Okay. So then r is going to be equal to r as it's defined on the previous line, right? And then to make it a percentage, we're going to take that and multiply by 100. Okay. So the annual interest rate is going to be rounded to 2 decimal places. So number form r infinity to 10.15%. Okay, so it doesn't seem to like what I did. Okay, so I have a feeling hold on one second. Hold on 1 second. 4250. Oh, right over here. This should be, okay, that actually should be plus, not times. So the initial, okay, my initial amount got screwed up. Let's try this one more time. Oh, you know what? I have to clear R. Okay, clear R. Oh, that's a pretty large interest rate. 16.37%. Yeah, so the problem, okay, so yeah, my answer is correct. So the reason my initial answer was wrong, excuse me, the reason my initial answer was wrong, guys, is because right over here, I did times instead of plus. Right over here. Okay, right over there, I did times instead of plus. Okay, so that was a little bit of a mistake, but you know, I was able to fix it. So right over here, I had times instead of plus, but you know, that's a mistake. It's $57 plus 0.6% of the principal. And what I did over here, I had times, okay, which is not correct, right? That's not correct, okay? But that's okay, I was able to fix it. So the answer for this problem is 16.37%. All right, so the problem is a little bit tricky. The formula is easy, but you have to, what's tricky about the problem is that you have to, you have to modify the initial and final amounts before you use your formula. That's the tricky part of this problem. Okay? All right, guys, that's going to be it for now. And there will be more videos in the future. I don't want the videos to become super long. So I'm probably going to have to post a lot of short videos. Okay? All right, guys, take care. And we will communicate at some point in the future.